Okay, in this video, we're going to move on to chapter 8. And I want to go over number 15, which is a comprehensive problem. And if you get an understanding of this problem, then you should have a pretty good sense of the primary content of the chapter. Number 15, normal population has a mean of 60 and a standard deviation of 12. You select random samples of 9. Now, here we have the key difference between chapter 7 and chapter 8. In chapter 7, we calculated z values, but they were for individual observations or individual values, one single value. In chapter 8, this whole process of sampling is introduced. And in this, as we look at samples, instead of taking one value, we take a sample of a certain sample size. In this case, it's 9. And then we calculate a z value for that particular mean, that sample mean. So again, here for A, apply the central limit theorem to describe the sampling distribution of the sample mean with n equal 9. With the small sample size, what condition is necessary to apply the central theorem? Then we actually are asked to calculate the standard error. Then we have probabilities, mean greater than 53, less than 56, between 56 and 63, and then F, the probability that the sampling error would be 9 or more. So let's go through those individually. In terms of A, when we apply the central limit theorem, essentially what the central limit theorem says is this, okay? If we have a normal distribution, then when we plot the means taken from that distribution, then those values will also be normally distributed. However, if we have a non-normal distribution, for example, if it's bimodal, if it's inverted, if it has thick tails, positively skewed, negatively skewed, whatever the case may be, then in order to assume normality, in order to assume that the distribution of the sample means is normal, we would need to have a sample size of 30 or more. Now, some textbooks will tell you 40 or more. Your particular textbook authors go with 30, and that's fine. And throughout this course, you will always be told when the population standard deviation is known or if it's unknown, and then the corresponding sample size. And as we'll find out in subsequent models, we'll discover that if it's not known, we'll have to use a different distribution. But anyway, getting back to the question at hand, with the small sample size, what condition is necessary to apply the central limit theorem? Well, the condition would be that the population would be normally distributed. Okay, that's going to be it's going to be the condition that's going to be necessary there. I went ahead and worked out some of these others. So let's go through these. For part B, what's the standard error? Remember that the standard error is the standard deviation of the sampling distribution of the sample means. Okay, and we calculate the standard error by simply taking the standard deviation divided by the square root of the sample size. So in this particular case, the standard deviation is 12. The sample size was 9. So we get 12 over the square root of 9, which is 3. So the standard error is 4. Okay. What's the probability that a sample mean is greater than 63? And again, we're not saying what's the probability that a particular individual value of 63. We're talking about a sample mean is greater than 63. So here we're going to take, this is going to be our standard equation. We're going to take the mean of 63 minus 60 over the standard error. We've already calculated that up here. So 63 minus 60 is 3. The standard error was 4. So we get a corresponding z value of 0.75. Here, once again, we go to our charts. We look at 0.75. We want something larger than, so we're looking at the smaller portion. So we go to 0.75 in our z-chart. And that happens to be 0.2266. So the probability is 22.66%. For D, what's the probability that the sample mean is less than 56? So I've got this graphically shown here. We've got less than 56. So we're going to take 56 minus 60, -4 over the standard error of 4, and we get a -1. Okay, so we're going to go to a z-value of 1. We're going to look for the smaller portion, and that is 0.1587. Okay, again, looking at the chart, go to the z-value of 1 and smaller portion 0.1587. And then for E, and E is the more interesting question, along with F. Okay, for E, what's the probability the sample mean is between 56 and 63? Actually, the more interesting one was F. Here we go ahead and we just put in the Z. We've already calculated the Z values for both 56 and 63. They are -1 and 0.75 respectively. So I've gone ahead and drawn the curve. You'll see that the area to the mean from a z-value of -1 back to the mean 0.3413, from the z-value of 0.75 back to the mean 0.2734. So combined, that's 0.6174. And then for F, what's the probability that the sampling error, which would be the sample mean minus the population, would be 9 or more? That is, what is the probability that the estimate of the population mean is less than 51 or more than 69? Okay, in this particular case, we need to come up with z-values for both 69 and 51. Okay, and the z-value for 69, we're going to use that same basic equation. 69 minus the mean of 60 is 9. The standard error was 4, 9 over 4.225. So the z-value that would correspond to a sample mean of 69 is 2.225. And we see that over here, 2.225. 51, instead of being 9 above 60, it's 9 below 60. So we're going to have a -2.225. So we're going to look down here, this z-value of -2.225. So if we want to find the area outside of the area between 69 and 51, we can either take this area and this area, add them up and subtract from 1, or we can just look at the smaller portion for 2.25. Okay, so we want for 2.25 on the z-distribution, we get a smaller portion of 0.0122. Hopefully you can see that okay. If not, definitely take a look at yours. So that's going to be the area. This area above 69 is 0.0122. The area below 51, another 0.0122. We add those two together and we get 2.244%. So there's a little less than a 2.5% chance that it will be less than 51 or greater than 69. Okay, I know this is a short video. I hope that helped, and that should help you with any questions you may have related to Arizona normal curve where we're using sample means as opposed to individual values.